What's up, guys? Welcome today to my channel. Welcome to AGIT Codeworks, and today we are going to be talking about one of the core concepts again in programming, and it's called functions. So we're going to be looking at functions, and we are going to be looking at functions with regards to the C programming language. So now, first of all, let's go through the objectives of this particular tutorial. We are going to look at a couple of few things, and then we're going to head straight to the dev C++ interface, and we are going to write these programs. All right, first of all, let's look at the objectives of this course. First of all, what are functions? Okay, first of all, a function is a reusable group of statements that can perform a task. Take note of that. A reusable group of statements, plural, take note, that can perform a particular task. Usually, in most languages, you have functions that make certain tasks easier for a programmer. Example, printing, getting input, getting output, and so on and so forth, building interfaces, and so on. Now, we're going to be talking about functions that you can build on your own. Okay, we're going to talk about building your own functions in C programming. First type of function we'll look at is what we call a void function. A void function. Now, a void function is basically a function that does not have a return type. It does not return anything. Okay, the explanation will come when we write the code, but just take note, whenever a function is started with the statement void, it means it does not have a return type. The next type is functions with a return type. And these are basically functions that return a particular data type to the calling function. Okay, like I said, we'll clear up all this when we write the code. Then lastly, we're going to look at functions that take arguments. That means functions that get a form of argument or a parameter from the caller before it executes. Okay, it's also worth mentioning that functions basically make programming a lot easier than it should be, for one reason: reusability. The word reusable. That's in the sense that, let's say I have a very complex mathematical algorithm, or I have a function that performs a security check or authentication. If I write such code and store in a function, it means I could reuse it on any other project or any other task without needing to rewrite that code. That's basically the main things functions are all about. Now, let's look at this and let's get how this works. So I go to dev C++. That's my IDE for developing C code. So what you are seeing here is the basic structure of a C program. Okay, if we wanted, we could start it from the beginning. You start by including the standard library with the include preprocessor directive, include standard library, the standard input output library, and then the other standard library too, which is stdlib.h. Now, what is this basically? Now, this is basically, we actually call them preprocessor directives. What they do is that they contain the default functions available in C, like basic function for printing stuff out, getting input from the keyboard, and so on and so forth. Okay, so then every C program would have a first default function, which is main in this case. So main is the function the compiler goes straight to whenever you run the code. Whenever you run your C code, it executes this as the first main function. All right, let's look at how functions work now. So let's first of all start by creating a simple function. Remember what I said, that functions are a reusable group of statements that can perform a task. So let's create one simple function. So let's say I need a function that will just print out my name, right, my occupation, and my age, so to speak. Okay, does not take arguments, does not return nothing. So it starts with void. Remember what I told you, void means a function without a return type. So I say void, let's call it display name. That's the name of the function. So this will be a function I'm creating now. So any code I put in here now becomes the task display name would call. Okay, so let's go. So let's say this code is supposed to print out, hello, my name is Chris. Change line. Do the same for a second line. It says hello, I am, okay, I I'm a data scientist, right? And one last line. Age is 5. Of course, that's not my age. All right, so let's go. So basically, functions are usually not as useful functions are usually not as straightforward as this. But what we're trying to demonstrate here is that how we can create a synonym. I call it synonym for a reason. If I call display name, it would end up calling these three functions, right? These three statements, I mean. So display name is a synonym now for these three functions. So let's compile and run this code first of all. Compile. So from my compiler, make sure you have 0 warnings, 0 error. So haven't done that. We run the program, execute here, then run. So you notice nothing is printed out. Why? Now that takes me to my next point. Functions don't perform their task until they are called. So what I'm saying here is I've just created a function called display name, but it is not yet called, so it does not perform its task yet. If at a point in my program I need to use the function, then I can say display name. Easy peasy lemon squeezy. So if I compile now, remember this is a compiled programming language, so with each change you make, you recompile. So error 0, warning 0. So now the function performs its task. So we run it, we say hello, my name is Chris, I'm a data scientist, age is 5. So just as an example, now imagine I ended to do this 10 times. Life is a lot easier because I just have to run this code 10 different times, right? Exactly. So I just get this happen 10 times. Very simple. Okay, so now this is for a void function, does not have a return type. Next, we want a function with a return type. For example, let's write a function that would add 2 numbers and give us a result. So let's say we want to have a function we can use to add numbers. So this time around, instead of void, it starts with int, not add, int. Hence, int becomes the return type. So void means no return type yet, int means a return type. So it's going to return an integer at the end. So after int, I call it add. Add becomes the name of the function. Open and close. So what does this add do? Now, I also talk about functions that take an argument. Because the function needs to know what it is adding, so it's going to take 2 numbers. That is 2 numbers we're supposed to add. So we have int a, and here we have int b. So let me explain. Here we have a function called add. The return type is int, and then it takes 2 parameters, arguments, int a and int b. That means it needs a variable here and another variable here, and 2 of them will be numbers. These numbers will be added when we call the function, not while we define the function. But during definition, we can as well add what it's going to do with those 2 numbers. So it's going to simply declare another variable called c, which will be equals to a plus b, and then return the answer c. Now that's the major difference. Something is returned. Return c. So this is a function with a return type. So return c. As we have this here, this has become a reusable function for adding numbers. So you will never have to write the code for adding numbers ever again. Anytime you want to add 2 numbers, you can just give them to the add function. They will add it and return the answer to you, right? Okay, of course this is a simple task, but you can look at this from a more complex perspective, where you have like a complex algorithm you have in a software you are building, and you do not want to repeat that task. Functions help us achieve that. Pretty much a lot of programming languages use functions, so it's a concept that when you understand right here in C, it becomes a lot easier even in other languages. All right, let's use our addition function. So let's have 2 numbers I want to add. I want to add 100 and 500. It becomes simple now. I could just say, first of all, I want my answer stored here. I want my answer to be returned in a variable called answer, right? ANS, not answer. So you say equals to, I say add, and what is it going to add? Let's say it's adding 120, 20. So automatically I can add two numbers pretty much anytime. So print out my answer. Answer is printf. The way C formats output, the format for printing out an integer is %d, right? So to print out my integer, let's say answer is, then I say %d. That's how printing in C works. So to give it a variable to replace this %d with, you have a comma, then you put ANS, answer. So it's going to print out answer is whatever the result here is. So I repeat again, in C, the printf function for printing out basically prints out based on a format. If it's an integer, I put a %d, then I take the second argument for the printf function, will give the variable answer, which is going to be replaced with this %d. We will replace this %d. Alright, and by the way, printf is actually a function that comes with C. It's pretty much like our functions, but basically it's an implicit function and it was defined. It's defined in the C compiler. So once you install C, you already have it. This, on the other hand, is a second way for us to write more functions to extend the capacity or capability of our programming environment. Alright, let's see our result. We are going to compile first. There's no error messages. Then we run the code. So we get answer is 140. Let's say we change our mind. We have two other numbers we want to add, like 15 and 30. So I go 15 here, add 15 to 30. Right? So we compile this and then we run this. Answer is 45. So this is at a very basic level how functions work. Please do subscribe to my channel if you found this useful. You can also like and comment on the video, and just follow me for more awesome tutorial on programming and anything ICT. Alright, do have a wonderful rest of the day.